Hi, I'm Ehsan Garner with Michigan State University. In this video, I'm going to talk about saturated buffers. A saturated buffer is a conservation drainage practice that reduces nitrate from drainage discharge. NRCS has a standard code 604 for this practice. Before we talk about the saturated buffer, let's look at the water components at a subsurface drain farm. So you can see here, these are the water components. Precipitation is an important component here. When precipitation comes on the field, if it's an intense rainfall and it exceeds the rate of infiltration, surface runoff occurs. Some of the rainfall infiltrates and it infiltrates into the soil. Some of it goes to the crop uptake. Some of it goes to lateral seepage, some of it goes to deep percolation, but an important part of that is drainage discharge. And that's where the soluble nutrients are. So we're going to look at a saturated buffer to see how a saturated buffer can help reduce nitrate loss. This is the diagram of a saturated buffer. As I mentioned, a saturated buffer targets nitrate loss in drainage discharge. So as water enters the lateral drainage pipes, it enters the main pipe and water reaches the edge of the field. When water reaches the edge of the field, there's a controlled structure there. Water in the controlled structure rises up because there's stop logs in the structure, and with those stop logs, we can divert water into these perforated distribution pipes. These perforated distribution pipes are under the ground and they run along the length of the ditch. As water comes out of these pipes, it slowly seeps through the soil to eventually some of it reaches the ditch. As water is moving through the soil, the process of denitrification occurs. With denitrification, nitrate gets converted into nitrogen gas. So in this way, a saturated buffer can reduce nitrate loss. A saturated buffer also allows for controlled drainage implementation. Controlled drainage is also known as drainage water management. This is the top view on the left. There's a subsurface drainage system here that brings water to the edge of the field through the main pipe. Water enters the structure, and this is the distribution pipe. So we're looking from above, and this is a ditch, and this is the bypass of the system. So extra water that comes in that cannot be handled by the distribution pipe moves through the bypass pipe to the ditch. So let's look on the right. This is the side view of the same system. And this is the ditch on this side. This is the channel bank. This is the structure. This is a 3-chamber control structure. And this circle here represents the distribution pipe. So you can see as water comes through the main pipe into the structure, water goes through the first chamber. The first chamber is where you can implement controlled drainage. The controlled drainage component gives additional benefits for water quality and also potential crop yield benefits. And as water goes over the first chamber and into the second middle chamber, that's where water is diverted into the distribution pipes. And from there, extra water that cannot be handled by the distribution pipe goes in the third chamber, and from there, it goes in the ditch. This is the bypass section of the system. So saturated buffers allow for controlled drainage. So they offer an additional water quality benefit because it's a stacking of controlled drainage and a saturated buffer together here. What are some of the site characteristics that we should be looking for to install a saturated buffer? First thing is that we need a well-established vegetation like grass, shrubs, and trees. If you have the grass, you can mow or burn the grass in August. For more information, see our other video. If you don't want to do any stop-log management, by that I mean that you set the stop-logs at a certain height and you do not manage year-round. In that case, you need to be looking for slides with slope of about 2% or higher. The reason for that is that the crop land is at a higher elevation than the buffer. So when we raise the water table in the buffer, that's not going to affect the crop land. If you choose to implement controlled drainage and then get the additional bonus water quality benefit and the potential crop yield benefit, in that case, you need to manage the water stop logs inside the control structure. In that case, look for sites with slopes of about less than 2%. And also when you're looking for sites, avoid sites with surface inlets, because surface inlets move sediment into the drainage system, and that sediment could end up into the distribution pipe, and slowly over time it could clog and reduce the performance of the saturated buffer. To give you an idea what I mean by stop log management, this is a side view of the control structure at the edge of the field. So the management, if you're doing option 1 that I mentioned, that you're looking for a steep field and you do not want to manage the stop logs throughout the year and you want to set it at a certain height and not changing it, in this case, you just put the stop logs, both will be equal, both. You can see in this graph, and you just leave it there. In the other scenario I mentioned, you would be managing them. So the management basically would mean that both these two stop logs would change at the same time. So if the first stop log goes lower, then the second one is going to have to go lower. So they have to be at the same height all the time. What's the difference between a saturated buffer and a buffer strip? When the problem is surface runoff and erosion from the edge of the field into the drainage ditch, in that case, a buffer strip is going to be suitable, where you can see in this photo, there's a grass buffer here, reducing surface runoff and reducing erosion. If the problem is nitrate in the drainage discharge, and also the same as before, also surface runoff, then in this case, a saturated buffer is going to work, because the saturated buffer is going to help reduce surface runoff because it's got a buffer strip on the surface, and also it's going to treat nitrate in the drainage discharge. In summary, a saturated buffer is a stacking of 3 different practices that provide additional benefits. The first one is a distribution pipe. So as water comes down to the edge of the field, water gets diverted into the distribution pipe. The benefit here is that we get reduced drainage discharge and also reduced nitrate load. The second part is the controlled drainage part. And I mentioned that you can implement controlled drainage with this system. That helps reduce drainage discharge and nitrate load. So it's an added bonus to the water quality benefits of the saturated buffer. The third component is the buffer strip. As I mentioned, you can have grass, shrubs, or trees on the buffer area. So that will reduce surface runoff and erosion. For information about design, you can hire a private company or you can visit your local NRCS office.